We're going to be taking a look at virtual functions. What would happen if our base class and our derived class, the mother and the daughter class, were to have a function with the same name? Both of them have the attack function, for example. Which one are we going to end up taking? Well, it all comes down to whether or not we have the virtual keyword in front of the data type for the function inside of the base class or the mother class. So using some of the examples we saw last video, I have the enemy class and the terrorist class. Now we used the terrorist class and the alien class in the last video to create an attack function, and that attack function allowed us to determine how much damage each individual one was going to do, because we didn't want terrorists to do the same amount of damage as aliens. However, both of them were enemies, right? So they both went back to the enemy class to inherit some similar information about being an enemy. They know that we need to attack somebody for damage. Now, what would happen if we had an attack function inside of the enemy class as well? Which means we have the attack function inside the enemy class and the terrorist class. I got rid of the alien class for this video because we don't need the extra example. So let's go ahead and design the exact same function, obviously with a different statement inside of it, inside of both the terrorist class and the enemy class. So we'll start off with the enemy class. I already created our constructor and I wrote our preprocessor commands and our namespace definition, so we don't need to worry about that. I'll go ahead and write a void enemy, and I'll call this attack. So it's the attack function. And I'm just going to put one little statement in here, which is going to say you were attacked by an enemy. Simple enough. And now we need to prototype this. We're getting an error. So I go into the enemy header file and I'll just need to write it up here. So I can write void attack. Simple enough. And that will make the error disappear because now we have prototyped it. It's going to disappear right now. Okay. So now we can head inside the terrorist file. Now right here you see that I already put this here. I already indicated that this is going to be a daughter class. It will be inheriting from the enemy class. We see I wrote class terrorist. I put a colon before we get into the body. Then I write public enemy, which means I want to be inheriting from the enemy class, and I'll be taking the public and protected information that's listed in the enemy class, not the private. And then we have the base over here, and I already put our constructor. So I can actually go ahead and write the void attack function over here because I'm going to be putting it anyway. And now we can go ahead and put the exact same function, but I'll make it a little bit different just so we know which one we're going to end up using when we go to print this out. So I go terrorist function, and I'm going to go ahead and not the terrorist function, that's for the constructor. I want to go ahead and put the attack function. There we go. So I put the attack function in here, and I'm going to include that you were attacked by a terrorist. So see out, you were attacked by a terrorist. End line. Okay, so now we know that we have the same attack function. One of them is inside of the terrorist class, which is inheriting information from the enemy class. So which one are we going to end up using? Let's head into the main and find out. So I'm going to go into the main.cpp, and I'm going to go ahead and I'm going to create my object. So I can say that use terrorist class. I'm going to create the terrorist object. And now I'm going to go ahead and use the enemy class. I'm going to create a pointer object. I'm going to go and write enemy because I'm using the enemy class. I'm going to put a asterisk because I want to make a pointer. And I'm going to write enemy object. We only need one this time. We don't need two because we got rid of the alien class. And I'm going to assign this the memory address of the terrorist object right over here. So we have all that listed right there. Now we need to go ahead and use this to print out the attack function. So what happens if we were to go ahead and write enemy object, which is assigned the memory address of terrorist object? Remember, we do not need to put the asterisk again because it already knows we're dealing with a pointer. And I'm going to use this with a pointer separator, use the arrow separator right here when you're using a pointer to call upon something inside of a class. And I just want to go ahead and say the attack function. Now, what do you think is going to appear on screen right now? Is it going to say you were attacked by an enemy, or is it going to say you were attacked by a terrorist? Let's go ahead and build and run this and find out what the actual answer is. So it's going to say that you were attacked by an enemy, which means the enemy function, the base class, the function inside the base class, was not overwritten. If you have a virtual function, it will be overwritten, which means if I were to go here into the enemy header file, which is the base header file, whoops, I didn't want that to happen. If we were to go into the base header file, right over here where I prototyped void attack for the enemy, this is the one that has the material that's going to be inherited. If I were to write virtual before the data type, the keyword virtual, just in here, not in the CPP file, just in the header file, if I were to write this here, this means it has permission to be overwritten, which means the inherited class will be able to override this and put its attack function. So now if I go back here and leave everything the same and actually press build and run, we're going to see we still build succeeded, and now you were attacked by a terrorist, which means because this is a virtual function, you're allowing this to be overwritten by the attack function inside the terrorist CPP, which has the exact same name. It's going to be using this instead. So I hope you guys understood virtual functions. When you use the keyword virtual inside of the base class, it's going to be overwritten. When you use a virtual function, it does take up more time, but sometimes it will be necessary to do. Keeps things nice and clean. Hope you guys enjoyed. If you have any questions, remember, leave them in the comments below and I'll answer them as soon as possible. Hope you guys enjoyed this video and I hope you guys enjoy the rest of my C++ series.